Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SNIT Adur. Welcome to my new video. This is also a problem on LMTD method, that is problem number 5. Let us start the problem. Water is heated from 20 degrees centigrade to 50 degrees centigrade by condensing steam at 120 degrees centigrade. That is, here water is a cold fluid, that is because it is heated from 20 degrees centigrade to 50 degrees centigrade. So it is the cold fluid. It is heated by condensing steam at 120 degrees centigrade. But steam is the hot fluid here and it is condensing. So the temperature of the hot fluid does not changes. Okay. If the inlet temperature of water falls to 15 degrees centigrade, that is, if the inlet temperature of water actually the value is 20 degrees centigrade, if now if it is changed into 15 degrees centigrade, then considering the flow remains constant, what will be the net outlet temperature? That is the question. So we have to find out the outlet temperature when the temperature of the inlet temperature of the cold fluid is maintained at 15 degrees centigrade. Okay, that is the question. LMTD problem number 5. Water is a cold fluid. It is heated from 20 degrees centigrade to 50 degrees by condensing steam at 120 degrees centigrade. It is the hot fluid. And if the water temperature, inlet temperature of water is lowered to 15 degrees centigrade, while all the flow remaining constant, what will be the net outlet temperature? That is the question. Okay. All these data are given. Okay. And you have to find out the net outlet temperature T2 when T1 is equal to 15 degrees centigrade. That is the question. We have to first find out the value for LMTD. In both the cases, the LMTD value will be same. Okay, that's the concept in the problem. Okay, first you have to write the given data. Okay, I'm making two columns for cold fluid and hot fluid. Here the cold fluid is water and the hot fluid is condensing steam. Okay, condensing steam is the hot fluid. When the temperature, inlet temperature of cold fluid T1 is small T1 is given as 20 degrees centigrade, and the outlet temperature of the cold fluid is given as 50 degrees centigrade. Then, while considering the hot fluid, it is condensing. That means we have to consider it as a condenser. Therefore, capital T1 is equal to capital T2 is equal to 120 degrees centigrade. To find, we have to find the net outlet temperature, that is T2, temperature of inlet fluid, that is water, that is T2, if the inlet temperature of water, that is T1, falls to 15 degrees centigrade. Okay. Then solution. First, we have to find out the LMTD. For that, draw the temperature distribution diagram. There is the first step. Drawing the temperature distribution diagram. Here also, for the hot fluid, draw a straight horizontal line because the steam is condensing steam. That is, we have to consider it as a condenser. Hot fluid is condensing steam. Its temperature remains constant, that is inlet and outlet temperature is the same, 120 degrees centigrade. Outlet temperature cavity 2 also 120 degrees centigrade. Then drawing the curve for cold fluid, that is water. Inlet temperature of water is small t1 is equal to 20 degrees centigrade, 20 degrees centigrade, and small t2 outlet temperature of water is 50 degrees centigrade, 50 degrees centigrade. Then the left side temperature difference gives theta 1 and the right side temperature difference gives theta 2. Therefore, theta 1 is equal to capital T1 minus small t1, which is equal to 120 minus 20, that is theta 1 is equal to 100 degrees centigrade. Then theta 2 is equal to right side temperature difference, that is capital T2 minus small t2, that is 120 minus 50, that is theta 2 is equal to 70 degrees centigrade. Then we have to find out LMTD, that is logarithmic mean temperature difference. We know that LMTD is equal to theta 1 minus theta 2 divided by ln of theta 1 by theta 2, that is value for theta 1 is 100 minus 70 divided by ln of 100 by 70. That is LMTD we get 84.11 degree centigrade. This value for LMTD. Okay. The second condition given here is that the inlet temperature of water, actually it was 20 degrees centigrade. Now we are altering the inlet temperature of water from 20 degrees centigrade to 15 degrees centigrade. Okay. Then what will be the outlet temperature of water if the flow remains constant? If flow remains constant means we can take the same LMTD here. Okay. It is given that flow remains constant, therefore LMTD is same for both the cases. We have to first draw the temperature difference temperature distribution diagram. Temperature distribution diagram, that is for T2 is equal to question, and it for T1 is equal to 15 degrees centigrade, 15 degrees centigrade. Sorry, it's not 150, it is 15 degrees centigrade. Just a mistake. It is the hot fluid curve. There is a straight horizontal line because it is condensing. Okay. Now it is a hot fluid. It is condensing steam. And there is a curve for cold fluid. It is water. Inlet temperature small t1 is equal to 15 degrees centigrade. 15 degrees centigrade. Now outlet temperature of water T2 is the question. Then the left side temperature difference gives theta 1 and the right side temperature difference gives theta 2. Theta 1 is equal to capital T1 minus small t1, that is 120 minus 15, which is equal to theta 1 is equal to 105 degrees centigrade, and theta 2 is equal to capital T2 minus small t2, that is 120 minus T2. Okay. Substituting these values of theta 1 and theta 2 in the equation for LMTD. Okay, that's the next step. This LMTD is equal to theta 1 minus theta 2 divided by ln of theta 1 by theta 2. LMTD is equal to, for LMTD we have already found out at 84.11 degrees centigrade, already found out. Substituting the values, this LMTD is equal, that is 84.11 is equal to, value for theta 1 is 105 minus 120 minus theta T2 divided by ln of 105 divided by 120 minus T2. Then the next step is cross multiplying. Cross multiplying, we get ln 105 divided by 120 minus T2 into 84.11 is equal to 105 minus of 120 minus T2. While solving this, we get the value for T2 as 56 degrees centigrade. Okay, this is the answer.